All right, we're going to talk about how to apply a normal probability distribution involving the addition or subtraction of random variables. So here's an example that you may find in a book or somewhere else, but suppose that a mean height of a policeman is 70 inches with a standard deviation of 3 inches. And suppose the mean height of a policewoman is 65 inches and a standard deviation is 25 inches. If heights of policemen and policewomen are normally distributed, find the probability that a randomly selected policewoman is taller than a randomly selected policeman. Okay, and so if we have this, the mean of a policeman, so we'll call M is equal to height of a policeman. All right, and I'll call W is the height of a policewoman. It's my F of a policewoman. All right, and so we have our mean, which is 70 inches, and we have our standard deviation of M is 3 inches. And for women, we have 65, and we have right here is going to be 2.5 inches. Okay, now what we're trying to figure out is what's the probability that a randomly selected policewoman is taller than a randomly selected policeman. Well, let's think about this. How would we figure this out? Well, if we're comparing, whenever you're comparing two things, okay, is that we want to probably find the difference between them. So if we found the difference between men and women, okay, a man and a woman, all right, essentially what we would have is we would have a normal distribution because both are normally distributed. These two would be normally distributed. So if we found the difference between them and we took this right here, we found what is the mean of x minus y. All right, and so we said 70 inches, all right, minus 65 inches. We would have the difference between a man and a woman is going to be 5 inches. Okay, and let's say we found the standard deviation of this. Standard deviation would be, all right, we would take the variance and add that to the other value right there. And so if you took this one, you would have the square root of 9 plus the square root of 2.5 squared, and you would have roughly right about approximately 3.9, we'll go 0.5, all right, inches there. Now from here, let's think about this because I want to figure out the probability, all right, of where the policewoman is taller than a randomly selected policeman. So if we have our difference between these two, what would have to be true if they're going to be taller? And I'm going to just draw this curve right here. And we have our curve, and this is our curve of our two. So we have 5 inches is my mean. All right, I'll just put 5. And I also have my standard deviation of 3.905. All right, so this is 5 inches. What would have to be, all right, if a woman is taller, that means, well, essentially when they're equal to 0. Okay, equal to 0. And from here, if this value is bigger, so if this is 0, okay, right here, if the woman is taller, essentially that means we have negative answers. So our negative answers are going to be this value right here. So what we're looking for is when this value is going to be less than 0, okay? When the difference between these two is less than 0. Does that make sense? Hopefully that makes sense to you, because right here we're going to find out this probability. And so now to figure out this probability, we can go through and we can say, okay, what is going to be the z-score for this? And we can go to z-score, or we can put our normal CDF. So in any case, when I take this, I take my probability right here, okay, is we can do two different things. Is now I can use my normal CDF, and I'll show you how to use a calculator, but we can put our normal CDF And what we want to do is we're going to have our lower, all right, lower bound is going to be, let's just say negative 1,000, I don't know, all right. Our upper, all right, is going to be 0. We're going to have a mean of x minus y. That's going to equal 5. And then we have our, all right, standard deviation of x minus y. That's going to equal the 3.905. All right. Oops. All right. All right. 3.905. Okay. That's a 0. That's our 5. And we put this on our calculator. So when we're doing this, and I get to say that right there, you go to second distribution, normal CDF, which is 2. All right, our lower we're going to have is like negative 1,000. That's what I said. And then we have our upper, which is 0. All right, we're going to have our mean, which we said was 5. All right, and the normal or the standard deviation, which is going to be 3.905. I'm going to paste that right there, and it's going to calculate our probability. So what's the probability of this happening? Well, this is approximately, as you can see right here, and I'll just take that and put it right there. We can find our probability. It's going to equal, all right, about 0.100, so about 10%. So there's a 10% chance that we will select that a randomly selected policewoman is taller than a randomly selected policeman. That's what we have there. We can also find this out by using a z-score and just doing the same thing. If you use a z-score, we could find the z value by taking, all right, 0 minus, because that's our value we want to find, minus our mean divided by, all right, our standard deviation, which is 3.905. Punch that into our calculator, so you have negative 5 divided by 3.905. And we have a z-score of negative 1.28. Once again, if you redid this, and just put this right here, make it red. And so we have normal distribution of 0 and 1. This is 0. We can go down here and be 1.28. But once again, we're trying to find this value. So we're trying to find the probability of our z-score being, all right, less than negative 1.28. And you can go through and use table A, but that's going to equal the same thing, which is going to equal about 0.1. Okay. All right. Well, here's another example of using probability distributions with adding or subtracting of random variables and helping find the probability of that. I hope this helps you out, and good luck and God bless in the rest of your problems.